So good morning once again. We're going to continue our discussion on multiple linear regression. So far, what we have done was to discuss the objective of multiple linear regression, which is to find the relationship between your dependent variable or response variable with your independent variable or your predictor variable or your predictor variables. And we looked at the general equation of a linear regression. Okay. So this is the equation of a multiple linear regression where your x and i's are your independent variables, they're your predictors, okay, and your y is your dependent variable. Okay. The betas here are the slopes, which indicate the marginal contribution of a particular independent variable on the dependent variable. So they're the slope coefficients for each explanatory variable, while beta null is your constant term. Okay, and E here is the model's error term, also known as the residuals. Okay, there are some assumptions that we looked into, and these assumptions are important in order to make our model. I think I failed to mention to you this one, blue. Did I mention to you blue, class? Did I? Yes or no, please? Paki-unmute na lang, please. Hello? Have I mentioned to you this acronym blue before?
No, sir.
No, okay. So when these assumptions, what are these assumptions? The linearity of the model, okay? The linearity of the parameters. I think we mentioned 6 assumptions. The variance of the error terms, independence of the residuals and normality of the residuals. When the model complies with these assumptions, then we have what we call the best linear unbiased estimators. Okay, so when these assumptions are met, then our parameters are beta 1, beta 2, etc. They are regarded as the best linear unbiased estimators. Okay, and also we said that the model uses OLS. Okay, it's the ordinary least squares. There is only one regression model for a set of data. So you have your dependent variable, you have your independent variable. There can only be one and only one linear model, best linear model. So let me just illustrate that by way of review. Okay, so I'll just write here, sorry. So this is our, so these are our data points. Okay, when we say best linear unbiased estimator using OLS, ordinary least squares. So in this case, let's assume that this is the regression line. Okay, there's only one unique regression line that minimizes. Okay, that's why it's called ordinary least squares. Okay, because it seeks to, if I draw a line here, the distance between your actual data point and your regression line. Should I use it? So these are what we call the residuals, right? We have explained this before. These are the difference between your actual data point, okay, this one, and your model. Okay. So they are your residuals, your error terms. Okay. When you sum up your error terms, we know that the sum will be equal to 0. Okay. So we don't use the error terms, the sum of the error terms as a parameter. Rather, as a basis for the model, we use the error squared. Error squared. Okay. So this line, which is your regression line or the line of best fit, okay, it's a unique line, which means there cannot be any other line where the sum of your errors squared are at a minimum. Okay. Minimize to, no? Wala. Let me clear it first. Okay, minimum. Difficult to write here. So the objective is to find that regression line, that line of best fit that minimizes the sum of your errors squared. And there can only be one line. Okay, there can only be one line that 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 minimizes the square of the error terms. Okay, that's why it's called the line of best fit. Best fit. Okay, that's the line of best fit, and it's a unique line, no? Which means isang line lang yan. So if I, for example, choose another line like this, okay, kunyari yan yung line na napili natin, and if you get the errors, no? The distance between the actual point and your regression line, and then square it and then sum it up, you'll see that the sum of the error squared for this line is higher than that of this regression line. Okay, that line is a unique line. Okay, and if these assumptions are complied with or are followed, then it will give us the best linear unbiased estimators. Okay. However, if some of the assumptions are not met, then it might not be your best linear unbiased estimator. And we'll take a look at that once we go to the diagnostics. Okay, so let me clear everything. Any questions, class? Is this clear? Yung best linear unbiased estimator, and then the method used, which I mentioned before, I think, is ordinary least squares. So this is where the squared residuals come from. Squares, squared terms of the residuals. Okay, and we call it the line of best fit, and there can only be one and only one line given your data points. Okay, kindly please chat if the explanation is clear. Do you have any questions? Feedback from the class, please. Thank you. Very good. How about the others? I only saw two. Yeah, thank you. Okay, so remember this, guys. The assumptions are very important because the assumptions will ensure that our model is the best linear unbiased estimator. Later on, class, when we go, for example, to the diagnostics for heteroskedasticity, we'll see what happens to the best linear unbiased estimator if the assumption of the constant variance is violated. Okay, so kunyari, remember one of the, okay, let me close first the annotation. One of the assumptions of the classical linear regression model is the homogeneity of residuals variance, which means constant yung variance natin. Pag hindi constant yung variance, okay, which means there's a spreading out, fanning out of your residuals across the values of your independent variables, then we have a heteroscedastic variance of the errors. So that will violate our assumptions, and it can affect your best linear unbiased estimator. Okay, so we already we were using the wage data set, okay, and we learned how to use descriptive statistics in R in order to understand the behavior, the nature of your data, and then we went to generating model 1, which is just a simple linear regression. So we use the LM linear model function, okay, and the syntax is that we identify first a dependent variable regressed against the independent variable, and we identify the data. So very quick. Let's have a very quick. Let me just run this quickly, and then okay. So let me just summarize the summary of mod 1. Let's just have a quick review of this one. Summary mod 1. Okay, so let's take a look at this. The first model that we generated, you have here education. The slope is 0.54, which means for every 1 unit, 1 year increase in education, there's a corresponding increase in hourly wage. Okay, $0.54 of hourly wage. This is statistically significant at 0.001. Okay, the intercept, okay, although it is not significant, we said that we always include this. We do not want the intercept to be equal to 0, okay, because the implication is that we will let the model run through the origin. Okay, so let me draw that just to make sure that we understand this. Okay. So if we draw the model, actually, since the intercept is negative 0.9, so it's about here. Right? So yeah, the straight. It's about here, negative 0.9. The intercept natin. If we do not include this, okay, even if it's not significant, right? What we're doing is that we are making the model cross the origin. Kasi if we zero this out, ibig sabihin yung intercept is 0, therefore the model is passing through the origin. Okay, so we're making the model pass through the origin. Okay, and there are reasons why we don't want that. So even if the intercept is not equal, the p-value of the intercept is greater than 0.05, nevertheless, we still include that. Okay, so this was our first model. Okay, and what's important to see here is that the adjusted R squared is 16.32. Okay, the overall goodness of fit. Okay, let me because I don't recall discussing this with you. Okay, let me first clear everything. Right. So I don't think I have discussed this with you. This F statistic. Okay, so this test, it's a statistical test, and we call it the overall goodness of fit test. Okay, so what's included in this test? What's included in this test is that your parameters. So there are only 2 parameters. You have beta null, which is your slope. So this is our null hypothesis. So remember, class, this is your F statistic. So it's coming from a statistical test. And the statistical test is that your null hypothesis is that beta null is equal to beta 1 for your education is equal to 0. Okay, so this is the test. This is beta 1. Okay? This is the test that we're doing. And what is our conclusion? Remember, if you're doing a statistical test, you make an inference about it, whether we should reject the null hypothesis or fail to reject the null hypothesis. The p-value is practically 0. Okay, so it's less than 0.05. Okay, this one. That's actually 0.000, 15 zeros and then 1 6. So you have 15 zeros there. And it's much less than 0.05. Therefore, our inference is that we reject this null hypothesis. So reject. We reject this. We reject that beta null is equal to beta 1 is equal to 0. So there's a statistical reason to believe that at least one of these, either beta null or beta 1, is not equal to 0. Okay, and the f-stat is 103.4. Okay, question, how did we get the degree of freedom here? 1 and 524. That one I think I discussed with you. Anyone, class? So for your overall goodness of fit test, which uses the F statistic, where this is our hypothesis. No? H null is beta null is equal to beta 1 is equal to 0. And our inference here is that we reject the null hypothesis that beta null is equal to beta 1 is equal to 0. That's why this is called, class, the overall goodness of fit. Kasi sabay-sabay nating hina-hypothesize yung mga parameters. No? Beta null is equal to beta 1 is equal to 0. Okay? And then sa output natin, you have 2 degrees of freedom, df1 and df2. Degree of freedom 1, degree of freedom 2, and then we have the f-stat, the p-value. This is the f-stat. Okay, how do we get the degree of freedom 1 here, class? Please, anyone? Hello? (524 minus k minus 1). Okay. Thank you, James. But that's your, ito yun, sa 524. Saan nanggaling 524? Okay, sige, explain ko ah. Yung degree of freedom, sorry, may answer. Observations minus 1. There are 526 observations. Okay. Sophia, observation minus k minus 1. What's your k? Ito muna, itong degree of freedom 1 muna. Where did we get that? df1. This is your df1, this is your df2. How do we get our df1, class? df1, df2. It says your df1 is equal to 1 and df2 is equal to 524. Where did we get? Wala yung annotation natin. Where did we get degree of freedom 1, class? Where did we get this? Okay, the degree of freedom 1 comes from the number of predictors. Ilan ba yung predictor natin? Isa lang, di ba? Education. Only one predictor, so degree of freedom is equal to 1. Degree of freedom 1 is equal to 1. If there were 8 predictors, then degree of freedom 1 will be equal to 8. So yung degree of freedom 1 refers to the number of predictors. Tapos yung degree of freedom 2, so that's your n minus k minus 1, diba? Where n refers to your number of observations, which is 526, okay? Minus k, which is your degree of freedom 1, and then minus 1. So 526 minus 1 minus 1, that's your 524. That's your degree of freedom 2. Okay? Now the one here, okay, the one here accounts for the intercept. So we will still have to, there is 1 degree of freedom lost because we will still estimate the intercept. Okay? So I hope this is clear to us, class. It's important that we understand almost all of the elements here sa regression output. And then this one, this is important to us. Instead of the multiple r squared, this is more important to us, the adjusted r squared. And this tells us that 16.32% of the variability of your hourly wage, kasi ito yung tinitingnan natin, di ba? Yung variation ng dependent variable natin. The 16.32% of the variation of the variability of your hourly wage can be explained by education. So what happened to the rest, to the other 83.68%? Well, it means that it can be explained by other variables and not education. Si education ang kaya niyang i-explain yung 16.32% lang. Okay? All right, I hope that's a okay. Any questions, class, before I clear this? Pa-chat naman please kung clear so far yung review natin na to na ng yung anatomy nito ng ng regression output natin. Okay, so lahat kasi ng regression ganito di ba? Yung output natin dito. So it's important for us to understand kung ano yung mga laman nitong na to, regression output natin. Okay, waiting for the rest to give their feedback. Okay, hindi pa nangangalahati, guys. Let's just wait for the others. Please feel free to ask questions if you have any. Not even 50% of the class are responding. How about the rest, guys? Hindi pa ako nakakuha sa inyo ng ng more than 90% na feedback. Are they still here or nagpa-attendance lang tapos wala na, hindi na umattend? Please respond, guys, kasi gusto ko malaman kung ano yung understanding ng class. This is quite a technical subject and hindi para sa akin hindi acceptable yung 10 lang yung magre-respond or not even half. Okay, paki-respond naman para alam ko kung naiintindihan din ba ng class or do I need to explain more? Okay, how about the rest? Kasi pag ganyan, class, pag hindi nako-complete, ibig sabihin, nagpa-attendance lang, tapos nawala na, hindi na uma-attend. Wala. 8 students are not responding. Okay. Okay, then we learned how to plot. Diba? Plot natin to. All right. So this is our regression line. Ito yung model natin. Okay, just to drive home the point. So if we just extend this line, diba? Ito yun, di ba? Ito yung extend ang line na yan, di ba? So this is your intercept, no? Negative 0.9. Diyan sa papasok sa negative 0.9. Okay, so this is our model, and this is called the line of best fit. Wala nang ibang regression line na katalo dito sa line na to in terms of minimizing your squared residuals. Asan yung mga squared residuals natin? Where are our squared residuals? Ito. So this is our actual point, and then the distance between yan, this actual with the model, yung hanggang sa line na to, that's your E. That's your E. That's your error term. So if we put a line, if we measure the distance of each of your observations and measure the residuals, okay, and then sum natin lahat ng mga residuals, we will get 0. The sum of the residuals is equal to 0. So walang gamit to, no? So what we do for modeling, walang gamit to kasi 0 lang naman yung sum niya. What we do is that we get instead of summing the residuals, we sum the squared residuals and then seek to minimize this. I-minimize natin yung squared residuals, and that is this line. Okay? So I hope I have explained clearly to you. Okay, kung ano nangyari dun sa regression line natin. Okay, so let's go here. We did model 2 also, but remember, class, that we want the independent variable to be highly correlated with your dependent variable. So we check that using this function. Diba? Kinuha natin correlation ng data na wage. Tinanggal natin yung mga character variables kasi hindi natin pwedeng kunin yung correlation ng character variables. So negative C, which means remove 4 to 6, columns 4 to 6. Okay, let me flash the wage. Wage data natin. Okay, this is our wage data, education, experience, tenure. So columns 4, 5, and 6. These are categorical variables, character variables. So we cannot get any correlation out of this. And mag-error kasi pag sinama natin itong variables sa correlation. So what we do is we remove this. Okay, we remove this. That's why we have this function. Si wage brackets, which means subset natin. Kasama sila si rows, lahat ng rows, yung first, yung space dito, hindi na natin in-identify. Ibig sabihin, kasama si rows. And then negative C 4 to 6. Si column naman, exclude si columns 4 to 6. Okay? And then we use this round function to just limit the decimal places to 3. Okay. So very quickly, guys, ito na yung correlation nila, no? Yung diagonals dito, syempre 1 lahat yan kasi it's a correlation of the variable with itself. So 100% yung correlation with itself. And then what we're interested here is si hourly wage. How correlated is it with the independent variables? Notice ang pinakamababa si number of dependents, negative 0.05. So among these variables, si number of dependents ang hindi masyadong correlated with hourly wage. Now that's very important kasi kung hindi siya correlated, weak yung correlation niya, then ibig sabihin nun, si number of dependents cannot really explain. Hindi siya yung magandang explanatory variable for hourly wage. Ang pinakamalaki among our variables is education. And we already found out that education is a statistically significant predictor of hourly wage. Okay, so review na lang to class, no? And what we did was but before we did that, sabi natin, okay, so yung dating, saan yun? Yung dating, class, yung dating R, you have to convert first yung mga categorical variables to factors. Now, what happened was, I recall, last time when we ran this, okay na siya kahit hindi pa natin kino-convert yung categorical variables as factors. Let me check. Parang ko na yata. So just be aware of that. Class, wage, race. No? Race. Race is a categorical variable. So let me check. So na-convert ko na. No? Na-convert ko na siya as factor. But if you recall, class, last time when we ran this, hindi pa natin nako-convert as factor, pero nag-run na siya. Okay, so siguro that's a modification that was done with R na kahit na hindi pa natin nako-convert as factor, automatically kinonvert na niya on its own. Okay? So I myself was surprised kasi just last term when we were doing this, hindi pa siya nag-run. I don't know what happened. Maybe nag-update si R, no? So nevertheless, guys, what's important is we were able to generate the results at let me run this. Okay, so model 2. And then let me summarize model 2. Okay. All right. So again, this is the output. And we now see that education is significant, tenure is significant, gender is significant, civil status and race is not significant, number of dependents is not significant. And we learned how to interpret this. So very quickly, sabi natin, si education, it means that for every 1 year increase in education, there's a corresponding $0.57 increase in hourly wage. So the relationship between education and hourly wage is positive. Okay, it's positive. As education increases, hourly wage also increases. And then we have to include ceteris paribus. Okay, ceteris paribus. Ibig sabihin, all things being the same. Ibig sabihin, we cannot increase the other variables. Si education lang, increase natin ng isa. The rest, zero increases sila. They remain constant. Okay, so that's what we mean by ceteris paribus. And that's very important kasi pag magbago din yung ibang variables, kunyari, si experience magbago din ng isang year, di hindi lang magbabago tong yung 0.57 pati itong 0.02. Okay? So ibig sabihin nun, mini-measure na rin natin yung effect ng education at saka ng experience sa hourly wage. But what we're interested in first is the marginal effect of education on hourly wage. Okay, so we impose that yung ceteris paribus, all things being the same. Okay. All right. Education, we see that for every 1 year increase in education, there's a corresponding $0.57 increase in hourly wage, ceteris paribus. Experience, we have one dot here, which means this is significant at 0.10%, no? A 0.10 or 10%. Sa education kasi significant at 0.1% or 0.001. Okay, so ang standard, what's usually followed is significance level of 5%. No? So dapat at least 1 star dito as far as R is concerned. So experience actually, if we will be strict with the 5% level of significance, then hindi siya significant. No? Hindi siya natin isasama siya sa model natin. And then si tenure, ganun din, significant at 0.001. So this is definitely statistically significant. So what's the marginal impact of tenure on hourly wage? For every 1 year increase in tenure, there's a corresponding $0.13, $0.14 rounded off in hourly wage, ceteris paribus. Okay? And then ito, again, yung dummy variables natin. So automatically, sabi natin, si R, dynamify na niya yung mga factors, yung mga categorical variables. So only character variables that can be used as a classifier can be used as factors. Okay? Kunyari, may variable ka na address na isang person. If you're not going to use that as a classifier, then it makes no sense to use that as a regressor. Again, only variables, only categorical variables that can be used as classifiers. For example, you're doing a study on the behavior of students. So, meron kang variable na year level. So, frosh, sophomore, junior, senior, graduating. So, that can be used as a classifier. So, pwedeng gamitin yun as a factor sa natin. Kasi makikita natin distinction between the behavior of sophomore, freshman, etc. And how does R do this? Paano niya ginagawa itong pagdadamify? Sabi natin, tinitingnan niya yung alphabetically kung sino uuna, and that's what's used as a benchmark. Ibig sabihin, yung benchmark, yung gagawin niyang 0. Sa race, tingnan natin ha. So summary, race. Oops, wait, sorry. Hindi pala naka-attach. So wage, dollar. Okay. Sabi natin, no, ang level ng race, non-white at saka white. Okay, 54 yung non-white, 472 yung white. And non-white appears first, no, kasi alphabetically nauuna siya. So ito yung gagawin niyang benchmark. Ito yung gagawin niyang benchmark, or we call it benchmark or reference variable, or aka gagawin niyang 0 yan. So dito sa race, idadamify niya to. Lahat ng white gagawin niyang 1, lahat ng non-white gagawin niyang 0. Okay, and we learned last time na depende kung ilan yung levels ng categorical variable natin. So if there are k levels, there will be k-1 dummy variables. So dito, yung levels ng factor natin na race, dalawa, kasi dalawang klase siya, non-white at white. Therefore, there will only be 1 dummy variable. Okay? So race, white lang to. Bakit race white? Okay? So yung race white, si white yung 1. So si non-white yung reference variable. Now it's important to understand that because when we interpret this now, we will interpret yung race na white in relation to your race na non-white. Okay, so it's not statistically significant, pero let's assume that it's statistically significant. So this means that on the average, white people receive $0.11 more than their non-white counterparts, ceteris paribus. That's how you interpret this. 0.11. So see, white people receive $0.11 more than their non-white counterparts. So you interpret this in the light of the benchmark or reference variable, which is your non-white. Ito din, si gender male. And this is statistically significant. How do we interpret this? On the average, male employees receive $1.76 more than their female counterparts, ceteris paribus. Okay? And yung civil status single, okay, assuming it's not significant, no? But assuming it's significant, on the average, single employees receive $0.46 less, okay, less kasi negative siya, no? Than their married counterparts. Okay, so itong mga categorical variables natin, itong mga dummy variables natin, make sure that when you interpret this in relation to your reference variable or your benchmark factor. Okay. Right? Okay, let me pause for a while. Okay, quick review lang to guys. So, unless you want me to explain once again. Any questions about our discussion so far? Okay, take note that I'm painstakingly really repeating this kasi you don't really understand this in one sitting. So gusto natin na maging klaro siya. Okay, any questions about those regression outputs? Okay. Okay, good. Thank you so much, guys. No? Yan, mas mabilis yung mga reactions natin. Thank you. I appreciate, guys, your feedback kasi importante sa akin yun. Kung number one, if you're understanding my explanation. Number two, if you're still there. Kasi baka wala na yung iba sa inyo. Eh, no? Okay. All right. So here below, ano nangyari dito? F-stat natin, 43.54. Okay, take a look at degree of freedom 1, 7. Bakit 7? Kasi 7 yung predictors natin. Education, experience, tenure, race, gender, civil status, number of dependents. 7 yan. That's why we have 7 degrees of freedom, DF1. And DF2 is n minus k minus 1. So that's 526 minus 7 minus 1. So 518. Okay, saan ginagamit to, guys? Ginagamit to para ma-determine yung F-stat. Okay? Dati nung manual pa, we need this very much, no? Para for us to look at statistical tables. Pero ngayon kasi because with the advent of software, automatically na binibigay na. So basta alam lang natin kung saan nanggaling yung 7 at 518. And then, okay, again guys, ano yung overall goodness of fit natin? Ito kasi, di ba, this is the overall goodness of fit test. You have, write that again. So ano yung null hypothesis natin dito? Our null hypothesis is that H null ang hirap magsulat dito sa okay. Our null hypothesis is X ko na muna. Annotate again. Okay. H null is beta null is equal to beta 1 beta 1 is equal to beta 2 is equal to hanggang is equal to beta 7 is equal to 0, no? So kaya overall kasi pinagsasama lahat ng mga parameters natin. Beta null is equal to beta 1 is equal to beta 2 hanggang beta 7 is equal to 0. And what's our conclusion? What's our inference? Our inference is we reject the null hypothesis that beta null is equal to beta 1 is equal to beta 2 is equal to beta 3 hanggang is equal to beta 7. We reject that, no? Bakit? Kasi your p-value is less than 0.05. So remember, diba? If the p is low, which means less than 0.05, the null must go. So remember that. Generally, if the p or the p-value is low, pag sinabing low, depende ito sa level of significance, no? The null must go. Okay. So, madaling tandaan, no? If the P is low, the null must go. Yung low dyan, ibig sabihin, you'll compare it to the level of significance. And usually, it's 0.05. So, here, the P is way, way lower than 0.05. So, we reject the null hypothesis that beta null is equal to beta 1, is equal to beta 2, is equal to beta 3, is equal to ... hanggang is equal to beta 7. No? And then, what do we see here? The adjusted R squared. So, anong nangyari dito is that 36.19% of the variability of your hourly wage can be explained by your regressors, can be explained by your variables. Kanina, around 16% lang. Ano? Kung sa education ang ginamit natin, ang kaya lang i-explain education is 16%. Ngayon, tumaas to, no? 36%. Mas kaya nang i-explain yung variation ng dependent variable natin ng hourly wage by our model. Okay. By the way, guys, ito din, since may mga p-values tayo dito, may null hypothesis din to. Okay, ano null hypothesis nito? So the null hypothesis for education is that yung H null natin H null natin, no? H null natin for education is that beta 1 is equal to 0. So individual lang siya, no? Individual tests to. Ito mga individual test. Bawat isa may kanya-kanyang p-values, no? Ito overall. Isang p-value. So this is overall, sabi natin, di ba? Overall to, ito individual. So these are the individual t-tests. Okay? So they also have their own hypothesis, no? And these are the t-stat ang ginagamit natin dito, p-value. Dito naman ang ginamit sa overall goodness of tree, yung f-stat. Okay. Okay, I hope this is clear so far. Okay, so now what we do now is let's go to, okay, na-double pala to, no? Now, which is better? Which is better? Model 1, yung simple linear regression natin, or Model 2? If we just take a look at the adjusted R-squared, syempre, mas maganda si Model 2. Kasi, mas malaking variation ang na-explain niya. Diba? Ilan yung ano? Ilan yung adjusted R-squared niya? Okay, 36%. While on the other hand, yung simple linear regression natin, where we just used education as the regressor, 16% lang. Okay? So mas okay si model 2. So but we can use aside from the adjusted R-squared, we use what we call the AIC, no? Okay, so let me write here AIC model 1, and also there's another one, BIC model 1. Okay, what do we do? What do we use this for? Space. Let's also write okay, Control C, Control V. Okay. We're going to test kung sino mas maganda, no? Si AIC o si Model 1 or si Model 2. Okay? So how do we do this? We use AKIK. Sabi natin, I think na-mention ko na dati sa ito, no? Sa inyo. Lang. AKIK. AKIK. Information criterion. Okay? AIC, AKIK information criterion, and the other one is Bayesian information criterion. Okay, so this measures yung AIC at BIC, it measures information loss. So we will compare model 1 and model 2, and the decision here is the lower, the better. The lower AIC, the better, kasi mas lower yung information loss. So if I run this, okay, you can see here that AKIK AIC for model 1 is 277. Siguro mas maganda kung okay. Dito na lang. Mas para mas makita natin yung comparison. Dapat sinabay ko yung AIC, no? Okay. All right. So for model 1, the AIC is 277. For model 2, it's 2640. So definitely model 2 which is a multiple linear regression, which includes all the variables, is better than model 1. Also in terms of BIC, 2790 versus 2679. So definitely no how do I call it? No debate about that. Mas maganda si model 1, model 1 kay model 2. Okay, there's another way to test, which di-discuss na natin later, but let me just write that now. We can test for the ANOVA. Okay, we can use also ANOVA to test which is better. Okay, whether it's model 1 or model 2. Okay, so what do we find here? Kasi model 1, di ba? Ito yung hourly wage education. Si model 2, hourly wage regress on all the variables. And then we have here an F statistic, 28.202 na to, at saka yung probability na to. Okay, so importante, ano ba yung ano dito? Ano yung null hypothesis? Sulat natin dito. H null. Okay, let me explain this. Okay, so we have this null hypothesis. The restricted model is better than the unrestricted. Ano yung restricted model? The restricted model is the one that has less less predictors. In this case, ang restricted natin si model 1 kasi isa lang yung predictor niya. Yung unrestricted natin si model 2 kasi mas marami siyang predictors. And what does the F statistic tell us? It's 28.02. Right? The degree of freedom here indicates the difference between the number of predictors. So 7 minus 1, that's 6. And then the p-value is 2.2 times 10 to the negative 16. So our conclusion is we reject the null hypothesis. No? Diba? We reject natin yung null hypothesis na yung restricted model is better than the unrestricted model. Sino yung restricted model? Ito, yung model 1 natin, yung simple linear regression. Sino yung unrestricted? Yung multiple linear regression natin. So this one, the ANOVA, analysis of variance test, tells us that the hypothesis that model 1, yung restricted model, is better than the unrestricted model, okay, is rejected. Right? Reject natin na mas maganda si restricted model. That's not true. There's strong statistical reason to believe that the unrestricted model is better than the restricted model. Okay, pause muna ako, guys. Any questions? Okay, good. Good. Thank you. Thank you so much, class. Appreciate your feedback. So dalawa yung ginamit natin ng test, BIC, and the ANOVA to test whether one model is better than the other. Okay, thank you. Thank you for the feedback, guys. All right. Now, so ito yung model natin, di ba? Ang tanong, is this the final model? So how do we come up with the final model? Do we just remove all these variables na hindi significant? So do we write that our hourly wage is equal to negative 3.39 plus 0.57 times education plus 13.8 times tenure plus 1759 times gender? Ganun na ba, guys, yung natin, yung model natin? Okay, the answer is not, guys. We don't do that. We will do what we call a stepwise regression. Okay, so papunta na tayo dito sa stepwise regression. Ano yung stepwise regression? In particular, ang ginagawa natin dito is backward. Kasi dalawang klaseng stepwise regression, may forward at saka backward. Ano yung backward? Sa backward, we first model we first do a regression model which includes all the variables, and then iisa-isa natin tatanggalin yung mga hindi significant. No? Okay, so let's go to our model again, this one. Okay, so ang mangyayari dito, magsi-stepwise tayo, iisa-isa natin tatanggalin yung mga hindi significant. Hindi pwedeng tatanggalin lahat kagad. Okay, so one at a time. So what will be the basis of our decision? Okay, we will base it on the t-value. Okay, the lowest absolute value. Okay, so in other words, tanggalin natin, don't mind the negative. Tingnan lang natin yung pinakamaliit na t-value. Okay? So what's our, and that will be our leaving. Leaving, aalisin natin. Leaving. Okay. See this? Leaving variable. Let's take a look at the t-value. Which of this is the most lowest, no? Yung pinaka-minimum. Disregarding this absolute value lang, disregarding the negative sign. Okay, which variable, guys? Paki-chat na please. Anong variable dyan ang pinakamaliit na t-value? Okay, raise. Okay, correct. So the variable is actually raise, no? In-append lang dito ni R yung white to signify that this ang dami natin na 1 will be white. Pero the variable is raise, guys. Raise ang variable natin. White and non-white are the levels ng factor variable natin. Okay, you're correct, no? It's white. Ito. Siya yung pinakamaliit na t-value, and incidentally, it's also the highest in terms of p-value, 0.79. Okay. Sa lahat among the non-significant variables, si raise yung pinakamalaking p-value, no? As compared to the others that are not significant. Si number of dependents, 0.17 lang, si civil status, 0.12, si experience, 0.07. So among the non-significant explanatory variables, si raise yung pinaka hindi significant. So what will happen? Let's copy now. Okay. So gawin natin ngayon, tatanggalin natin si no? Let's copy this. Copy natin to. Control C. Now let's go here now. Okay. Control V. So we'll now have our model number 3. And tatanggalin natin si raise. Okay? So anong tawag dito, guys? Stepwise regression. Okay? So we have model 3, right? LM, ganun pa rin, no? Linear model, hourly wage regressed on. Ngayon, 6 na lang yung natin, regressors natin. Diba? Tinanggalan natin si raise. Again, anong basis ng raise? Okay, bakit natin ginagawa yan? Kasi we're doing what we call stepwise regression. Okay, and then towards the end, makikita nyo you'll see why we are doing this. Okay, so ganun pa rin yung natin, yung syntax. And then summarize natin. So let's run. All right. Okay, what happened here now? So still, education is significant, experience significant lang at 10%, and then si civil status hindi significant, si number of dependents hindi significant. Okay, si gender significant pa rin. All right, so this is now our model 3. Okay, so medyo nagbago yung mga coefficients. And if you take a look at this, so overall goodness of fit natin, still okay pa rin, no? We reject the null hypothesis that all of these variables or all of these slopes are 0. And then what happened to your adjusted R squared? Medyo tumaas yung adjusted R squared natin, 36.31%. Okay, so it means that our model, nung tinanggal natin si Ray's, na-explain pa, no? Yung adjusted R squared natin na tumaas pa. But okay, if you take a look at the multiple R squared, no? 37.04 nung ando dun pa si Ray's, dito yung multiple R squared natin 37.03. So mas mataas yung multiple R squared nung model number 2 natin. Not natural yon, class, no? The more variables you have, the greater will be your multiple R squared. That's why we don't use this, no? Okay? Kasi ang gusto natin sa isang model natin is a parsimonious model. Parsimonious model. The lesser the number of variables, the better. Kung mas, in fact, di ba, mas na-explain nga yung, kaya nga tinitingnan natin yung adjusted R squared. Kasi yung adjusted R squared will penalize your model if you keep on adding more. Sa multiple R squared class, dagdag ng dagdag yung measure na to pag nagdagdag ka ng variable. However, what we look at, as I mentioned, is the adjusted R squared. Kasi nga, pag nagdadagdag tayo ng regressor, i-penalize tayo. So that's why the adjusted R squared here is greater kaysa dun sa isa. Okay? Pause muna ako, class. Okay, any questions? With our first stepwise regression. Okay, good. Thank you. Thank you. Don't be ashamed, guys, to ask questions. Please. Okay, can I see the function for model 3? Okay, thank you, James. Model 3, this one. Yan ang model 3 natin, no? Pareho lang siya kay model 2, tinanggal lang natin si race. So we are now regressing hourly wage on education, experience, and newer gender, civil status, number of dependents. Okay? We removed race. Bakit natin tinanggal si race? Siya yung pinaka-list na contributor sa pag-explain kay hourly wage based on the t-value. Race white 0.257 lang siya. Okay? So, and in fact, the p-value niya is the least significant, 0.797. Right? So, we know how to interpret this, guys, no? We will not repeat that. By the way, just to review, ano ibig sabihin ng intercept na to? Negative 3.29, 3.3. Sabi natin, di ba? This is the average hourly wage of a person with no education, no experience, no tenure, who is female, who is married, and no dependents. Okay? But of course, we don't put any practical interpretation to that kasi wala namang hourly wage na negative. But yun ang ibig sabihin niya. No? And we do not put any practical, as I said, practical significance to that. All right. So, question. Sino mas maganda? Si Model 2 or si Model 3? Okay. In terms of multiple R squared, obviously, mas maganda si Model 2. Lagi, guys, the more predictors, the higher will be the multiple R squared. Pero hindi yan ang acid test. Ang acid test is the adjusted R squared. No? Kasi sa adjusted R squared, as I said, kino-compute yan na pine-penalize natin pag dagdag ka ng dagdag ng variables. So it doesn't make sense to have 100 variables kung hindi naman significant yung mga yon. Okay, so parsimony is the name of the game. The more simple the model, the better. Okay, so let's see. Compare natin AIC na lang, no? AIC. Okay, AIC. Model 2. AIC. AIC. Model 3. Let's see in terms of AIC, sino mas maganda? All right. So in terms of the ACAIC information criterion, it turns out that Model 3 is better. Turns out that Model 3 is better. Despite the fact that mas maraming predictors in Model 2. ACAIC information criterion, sabi natin, the lower, the better. Okay. So, statistical test naman, class, yung ANOVA natin. Let's see. Okay. Oops. Need to put some spacing. Yeah. So let's do the ANOVA. ANOVA. ANOVA, and then Model 2, and then Model 3. All right. So run natin to. Okay, let's see. Okay. So let me again write our hypothesis. No? H naught, the restricted model is better than the unrestricted. Okay, question. Which is the restricted model? So in this case, ang restricted model natin, yung name niya hindi pareho ng name natin. So si model 1 dito is hourly wage regression 1, 2, 3, 4, 5, 6. Ayan, 7. Kasama si race. So ang restricted model natin dito is model 2. Identify ko lang dito. No? Kasi baka actually sa ano natin, sa pagbigay ng name, ang restricted natin si model 3, right? Kasi si model 3, siya yung walang race. Si model 2, may race siya. Pero dito, yung pangalan niya kasi dito na ginamit, model 1 and model 2. So sino yung restricted natin dito? Si model 1 o si model 2? Pakisagot nga please, class. Which is the restricted model in this case? Dito sa pag-run ng ANOVA ni is it model 1 or model 2? Any answer? Paki-chat please. Okay, yes, thank you. You're correct. Si model 2 yung restricted. Bakit? Tingnan niyo yung tingnan niyo yung variables. So wag na kayo mag-depend dun sa model 1 and model 2 ng pangalan kasi baka malito kayo. Just take a look at the restricted. Sino yung mas konting predictors. Yun ang restricted. And what's our p-value here? What's our p-value? 0.79, di ba? So this is much greater than 0.05. So what's our conclusion? We fail to reject. Okay? We cannot reject the null hypothesis that the restricted model is better than the unrestricted. Okay, since the p-value is greater than 0.05, the conclusion is we fail to reject the null hypothesis that the restricted model is better than the unrestricted. So mas maganda si restricted, guys. Okay, we cannot statistically prove that the restricted, okay, we cannot statistically prove that the restricted model is not better than the restricted. Okay, so mas maganda, class, yung walang race na predictor. Okay, pause muna ako. Clear ba so far? Importante, class, naiintindihan natin to. Clear so far that the restricted model is better. So mas maganda yung walang race. Okay, good. Good. konti lang yung nag-chat. I appreciate you guys asking questions. Remember, this is a safe environment natin to, no? No question will be considered as a quote-unquote stupid question. Safe time sa environment na to. Okay, we're here to support each other and to learn. Okay, good. Salamat. Thank you for your feedback. Paano ulit malalaman which one? Okay, thank you, Kyla. My question dito si Kyla. Paano ulit malalaman which one yung restricted? Okay, yung restricted will always be the model that has fewer, no? Fewer predictors. Yun ang restricted. Okay, kaya kunyari, yung isa, yung model 2 natin kanina, no? Yung 7 yung ano natin, yung predictors. Tapos compared to the other one na 6 lang yung predictors. So sino mas restricted doon? Yung mas konti, no? Mas konting predictors, kaya nga tawag sa kanya restricted kasi binawasan natin. Yung isa naman unrestricted. So depende sa kino-compare natin mga models. Pero guys, dapat pareho silang dependent variable. Hindi kunyari may dalawang models tayong kino-compare tapos magkaiba naman yung dependent variables natin. Hindi natin pwede i-compare 'yon, no? Kasi dapat pareho yung dependent variables natin. Okay, so the restricted model is the one that has lesser number of predictors. So doon sa model natin kanina, model 2, 7 yung predictors, model 3, 6 yung predictors. So si model 3 doon yung ano natin, yung restricted. Pero nung pag nag-ano ba tayo na model 1 and model 2 lang kasi ni-name diyan ni R, okay? But just take note that the hypothesis is always the restricted model is better than the unrestricted. Okay, lagi ito yung hypothesis. Okay, so did that answer your question, Shiloh? Okay, good. Let me see, baka may baka may nag-question pa. Okay, good. Thank you so much, class. I appreciate the feedback. Okay, sige, punta na tayo. Balikan natin yung model natin. Ito. So, we're not yet done kasi may mga insignificant pa eh. May mga insignificant pa. 3 yung insignificant. So again, may magli-leading variable dito. Again, titingnan natin yung t-value, hanapin natin yung pinaka-least in absolute value terms. No? It turns out that the least in terms of absolute value is number of dependents. So 1.33. Okay, take note, hindi ko tinitingnan guys yung negative. Si civil status, mas maliit siya numeric algebraically. Pero we disregard the negative. Hinahanap natin yung absolute value, p-value, which is, in this case, yung pinakamaliit is 1.33. Sino ba yung mga hindi significant? Si experience, 1.7. Si civil status, 1.5. Si number of dependents, 1.33. Okay? Alright, so copy ulit natin to. Mas model number 4 na tayo. Control C. Okay. Living variable natin, alam natin, it's number of dependents. Okay, Control V. Tatanggalin natin si number of dependents. Let's remove number of dependents. Press them. All right. Yan na. Tapos, I'll make this model 4. I'll make this model 4. There you go. Okay, LM, hourly wage. Now we have 1, 2, 3, 4, 5. Lilima na lang yung predictors natin. We started with 7. Okay, we're now down to 5. Let's see. Run natin to. Okay. All right. And adjusted R squared, tumaas ba? 36.21 dito kanina. Okay. Interesting, no? Bumaba yung adjusted R squared, 36.31. Ito 36.21. Okay? All right, but we don't really base it just on the adjusted R squared, no? Sa statistical testing tayo. But nung binawasan natin ng isa, tinanggal natin si number of dependents, natural, bababa yung multiple R squared. But usually, the adjusted R squared can go up, but in this case, it went down. Pero let's see. Tingnan natin, mag-ano tayo dito. Tingnan natin dito. Mag-control alt I ako. Let's see, AIC. AIC natin. AIC. AIC. So this one is model 3 and model 4. Okay. Tingnan muna natin AIC, guys. Model 3 is the one with more variables, di ba? Yung 6. Si model 4 yung 5 na lang. Si model 3 kasama si number of dependents. Si model 4 hindi na kasama. Let's see. 2638. Okay, 0.8 to 2638.6. So, based on AIC, mas maganda si model 4. Mas maganda yung restricted model natin. Yung 5 parameters lang, 5 predictors versus si model 3. But let's use ANOVA. ANOVA, kasi ito formal statistical test talaga to. ANOVA model 3 and model 4. Okay? So ito yung 6 predictors, ito yung 4 predictors. Yung unrestricted natin si model 3, yung restricted natin si model 4. Let's test again. All right. So here, okay, remember our null hypothesis here is that the restricted model is better than the unrestricted model. The p-value is 0.184. Ergo, guys, anong conclusion natin? Sulat na natin dito para ano? Just to remind you, H null is that the restricted model. Okay, which is, guys, just to clarify, no? Model 4 yan, ha? Is better than the unrestricted. Si unrestricted, yung mas maraming variables, no? Which is model 3. Okay. Sa name natin, ha? Dito kasi kay Innova, iba yung pagpangalan niya. Alright, but what's important here is that itong 0.184. So, sino mas maganda, guys, na model? Yung restricted o yung unrestricted? Pakit-type na, class. So, sino pipiliin natin? Yung restricted na yung walang number of dependents or yung unrestricted na may kasama yung number of dependents? Silent chat, please. Which is the better model, class? Time na. Guys, quick. So, gusto natin makita yung final model na. Hello, class. Hello. Answer, please. Which is better, the unrestricted or the restricted? Model 4. Okay, thank you. So, okay, siya lang sumagot. So, ang sagot, guys, the restricted model is better. Yung pag sinabing restricted, yung mas konti. No? So, it made sense to remove yung number of dependents. Yung unrestricted natin, kasama si number of dependents. Yung restricted natin, hindi nakasama. No? And p-value is greater than 0.05. So, we fail to reject the null hypothesis na mas maganda yung restricted. Okay. So, magtatanggal tayo dito, no? Ano yung tatanggalin natin? We will still remove kasi may dalawa pa tayong insignificant eh. Pero tingnan niyo itong na civil status, halos significant na rin, no? 0.05. So, the leading variable is experience, 1.558. Okay, so, experience yung leading variable. Control C. Okay, let's go here. Need to create model 5, yes, kasi may mga insignificant pa tayo. So model 5, and then tatanggalin natin si experience. Remove experience. There. And model 5 to. Okay. Model 5, So ilan na lang predictors natin? 1, 2, 3, 4. Apat na lang. No? And then let's run this. All right. So we now have this model na, okay, significant na lahat, no? Significant na lahat. Education, tenure, gender, male, civil status. The adjusted R squared went down 36.04. Okay. Overall goodness of fit test, okay pa rin. Okay. And then let's test. Let's see, guys. AIC. AIC. And then let's compare model 4 and model 5. Let's see, based on AIC, sino mas maganda? Si model 4 o si model 5? Right, now here it's surprising, no? Mas maganda daw si model 4. Yung yung 5 yung predictors natin. Okay, it's almost time, guys. May I have a minute with your permission, class? Just to finish this. Okay, thank you. Thank you. All right. So in terms of AIC, guys, mas maganda si model 4, mas maliit eh. But this is just to show that AIC is just one of the parameters by which we choose among the models. Okay. But let's check the ANOVA. Control Alt I. I-check natin si ANOVA ng model 4 and model 5. Si model 5 natin yung restricted, no? If we run this, alright, ano nangyari? Ang sinasabi dito based on analysis of variance na mas maganda si model number 5. Okay? Kasi ang p-value natin is greater than 0.05. So based on adjusted R squared, mas maganda si model number 4. Bakit? Kasi mas mataas yung adjusted R squared niya. Based on AIC, mas maganda si model number 4 kasi mas mababa yung AIC niya. But based on the statistical test ng ANOVA, it turns out that mas maganda yung yung model 5, yung restricted, which means that it doesn't make sense including civil status as part of the model kasi hindi naman siya statistically significant. Okay? Right. So based on this will be our final model. Okay, all the variables are now significant. Okay, and here it turns out that on the average, male employees receive $1.71 more than their female counterparts, ceteris paribus, and then single employees receive $0.685 less than their married counterparts, ceteris paribus. Okay, so let me stop recording now.